Hello everybody and welcome back to another episode of building a computer in Minecraft. Yeah, so as you can see behind me, I actually have added to the map over here, as you can see. Here's a bit of a size comparison. This one is way bigger, but it's also more compact, so this thing is just massive and this thing is tiny. This thing must be missing some things. But then again, this one is way better, and actually it's bigger than that now. It's all the way out this way. It's probably up above this 2 more maps. So it literally fills 4 maps right now, which is ridiculous. So let's go ahead and take a look at the big map. This is the most up-to-date version of the map, where it gets cut off here. But basically, this is the most of the system. We have the ROM, the registers, the ALU, and the multiplexers all set up. And let's go ahead and get on over there and take a look at that. So this is the computer, and it looks a lot different when you actually buy it, because it is looks much smaller here than it does on the map, I would say. But it is still pretty big. So we'll go ahead and talk about this. We got these giant lines going across the top. What are these for? Well, I designed a system that will actually put these back into the A slot, or theoretically, you can also shove them in the B slot using this one, which is quite nice. So we'll have to add a function for that. I didn't add that yet. But that'll probably be one of the read-write functions. And speaking of functions, this thing has a lot of functions on it. We can, over here, we can actually go ahead and see all of them and see how they would look when we want to run them. So for this one, we have the AND state, which is just turning on the logic system. So by default, it's AND. Then you can switch it to OR by doing this. And then you can switch it to NOR by doing this and then inverting the multiplexer for that. And you can switch the NAND state on by just hitting this one and then hitting the AND state. So there we go, it flips them both. And then these are XOR and XNOR respectively. And then we also have not B and not A. So I know what you're all thinking. Can this thing actually compute things? And yes, it can. Is it finished? No, not at all. I'm gonna just say that right now. Not at all. Very far from being finished. And it has a lot of features that it needs still. For example, I would like this to be much more simple to use, because there is 40 switches you could flip, and I would like the machine to do some of the flipping of the switches. So let's go ahead and begin by writing a program on this thing. So over here, I got the A and a B here. So we're going to go ahead and do mathematics, and I'm going to show you all how we can do this in quite a few ways. Let me get my leather out so I can do these flippings. Because I had to fix this real quick just to add another line for the not A or not B, because I messed it up. But that's fine. So we'll go ahead and deal with this. Alright, so let's say you want to write something on one of these lines. The first thing you need to do is turn off the line. You need to get all... Wait a second. Oh, they were already off. You need to turn one of these lines off and set it so that way you can do that. The next thing you need to do is turn a line of ROM on. So you need to flip ROM on and a line of this off, and then once that's done, you flip this back on, and it saves that data. So that, boom, there we go. Then you're gonna want to come over here, flip the ROM off again, and probably save it in another data unit, unless you want to have 2 sets of data in the same thing. In this case, we have a B, which we're gonna put in there, because I want to do some addition to show you all addition and see how that works. So now as you can see, the B is here. Let's go ahead and flip it and save it. And boom. There we go. So now all we have to do is turn off this so we don't end up with a loop happening, which could potentially happen if you've written something very complicated. But that could happen. And then we're going to decide what we're going to do to it. Are we going to use a logic system or not? So if I want to use a logic system, I have to flip the logic system on. If I'm going to use a math system, I don't have to flip any systems on. And are we going to save it as an A or a B? Because the outputs will be saved again, if you want to save them again, in another register. So there's up to 4 registers. You can save up to 4 things on this. Very, very nice, very nice. Which I think we're just going to go with some simple addition, just to demonstrate what happens when you do addition. So we'll flip that one down, which causes this line to turn on. And in a second, we'll probably get the output back for that over here. See, let's turn this line on. So you could save that A again. If you wanted to save an A, then you could save an A. But you can also write a B by doing that. And that should cause this one to flip over to here. Boom. And let's say we wanted to save that one. So let's go ahead and save it real quick on a... technically, we could read up to 3 lines here, but I'm not gonna save this. I don't... Honestly, it's kind of useless to save it, but... Okay, maybe we're gonna do a different logic system. So that's a good demonstration of how this should work. Because this one should flip over to this one, because it's carrying over as it's doing addition. Let's say I wanted to switch that output from an A to a B output. I could do that. And that would allow me to theoretically duplicate numbers, but we'll not do that yet. Actually, it's probably important for me to explain what I mean by this. So I'm gonna go ahead and save that on a register, and then I'll flip the output of these guys off. So we'll go ahead and save it on this guy. So we'll turn that one off. So is it reading? Oh no, it's not. Oh, okay, it is. So boom, save, and that should save it over there. All right, so now we're gonna turn both of these guys off, and we're gonna. As you can see, I just accidentally reset them, but that's caused the loop here. What do we do about this? Well, you just flip that one out of position. You can flip this one out of position, or you could lock these guys both and switch the loop out. Alright, so we want to read this line. So boom, we're reading that line now, and that should toggle that one on. Which is right, I think it's right. I don't know why it's toggling that line, because it's not really supposed to be doing... I think that's not right. Why is it... Oh, wait, maybe it is. Maybe it is. Maybe... Yeah, that's right. Okay, but now let's say we want to flip it over to a B. So if we go ahead and over here and flip this to a B, that should cause all the B's to turn on, which will mean that, so now if we save it, we'll actually save 2 numbers here. So we'll go ahead and reset the save, and we'll save it again. Boom, and that should cause, no, it didn't cause anything. But that should cause the A to switch out, and then we can save it as a B. I think it did. Yeah, that did. Okay. So now I'm done reading that line, and I'm gonna go ahead and put in 2 new A and B inputs. So I'm gonna go ahead and do that real quick. Then we're gonna read both of these lines. So boom and boom. And then we can save that in register number 4. Or is this one outputting? That should, yeah, that should save in register number 4. Wait a second, but that is the same. Okay, because we have B still on, so it's actually outputting to B instead of A. But if we wanted to do this, we could just flip this back, and then we can go on over to here. Now, this is a big mess right now because I don't have any of the control circuitry in, which is very important to actually get this thing to go. So now we need to flip all these guys off, which I... Okay, let's go ahead and do this. Boom. Then we can flip these ones back to their normal states and unsave the data from them. So that's that done. And theoretically, you can continue this process forever and ever. So yeah, this is a 16-bit full adder. That's the whole circuit here. And it stores... These guys can store up to 32 bits, but you wouldn't really need to store 2 A and B inputs. You probably don't want that. Unless you wrote that in the code. So, what are we doing next to this machine? Because why isn't that finished, you know? So, I actually have some plans. We're gonna have converters to actually convert to hex and things like that. And then we're gonna also have things to convert into a monitor, and I'll have a data set to write letters. It's, yeah, big progress. So now, I'm gonna go ahead and, you know, start using some of these logic systems that we could use. So I want to do, let's go ahead and reset everything, because everything needs a reset. Is everything reset? I think it all is reset for the most part. Go ahead and check over. Okay, this one needs a reset, so we'll just flip that one off, flip it back on, and boom, reset. Let's go ahead and begin using some of these logic gates. So we have the AND state, we have the OR state, the NOR state, the that one state, that state, that state, that state. I don't even care what they're called anymore. But let's go ahead and write a system for these guys. So, we have the AND state. I guess I'll switch that one on. Not sure why not. Okay, let's go ahead and do that. So, AND, what is it saying is AND? What is outputting? Nothing should be outputting. There should be no outputs. Why is it saying that AND is an output? Oh wait, that's probably NAND. That's interesting. By default, the AND state is actually in the NAND state, which is interesting. So that means all these guys are going to be on, unless one of these is going to be off. So I did get that a little backwards. That's kind of interesting. Let's go ahead and write some lines on this to increase the amount of time it does not take us to do these things. So, and there we go. Let's go ahead and read this line. So boom, that's going to read that. We're going to go ahead and save that data somewhere. Alright, let's go ahead and flip this switch here. And we should have some outputs from that. Which might end up with a loop. But as you can see, we've ended up just getting rid of all of these guys. And it seems that only this A is on. And then all the other A's preceding that one. Which is very interesting. I did not expect this result. So, yeah, I guess it doesn't really handle the logic systems very well. It doesn't really enjoy logic systems, in fact. Let's go ahead and, I don't know, save the outputs from that and then use those. Let's go ahead and just save it. Boom. Saved. Now it's flipping over. Okay, so now these guys are off. This is, I did not expect NAND to be so interesting. Let's go ahead and save this again. And see what happens when we save this function. Let's go ahead and compare that to the other function. So we'll save that in there. And then we'll go ahead and take a look at this. So, as you can see, the first A is on, and the second A, or the first A is off on the other line. And then on this one, it seems that the B is off, and B is off, on. So it seems that it's just inverted itself, except in the middle here, we actually have this weird, it's like just a strange, where is it at? It seems these guys have decided they don't want to be on, which would coincide with the initial A and B input and the initial B input, but I cannot find the initial A input, which I don't know where that would be. It seems that it's just not here. It just does not exist right now. Alright, so let's go ahead and see this permutation of it, and see what happens when we flip this switch, which should cause a bunch of flips to happen in these things here. But it seems they have decided to stay the same. For the most part, they are the same at least. But let's go ahead and see if anything's changed. Nope. But I did have it set to read, so it should change eventually. Let's go ahead and see what happens when we flip another gate over. So XNOR by default tests if both are true, or both are the same. So if both are the same, it should be off, well, on. But because one of these is different in most of them, it's gonna be pretty much, you know, except for this one. This one doesn't seem to be doing anything weird. Why is this one not on? Okay, let's see what happened here. Well, that explains it. This whole section is missing its redstone dust. Very disappointing. But that should turn a input on, which will be interesting. And then we'll do some addition with this. We'll just save that A in there. So yeah, that's pretty much the whole computer, and I think I'm done for today, because I've explained a lot of things about this thing already. And, I mean, I could explain more tomorrow in the next episode, but you know what? I think that's a good enough explanation of how this thing works, so if you all have enjoyed today's episode, please consider liking and subscribing. If you guys got any comments, questions, or suggestions, leave them down below. I'll see you all next time, and hopefully I can start adding some peripherals to this thing, because this thing needs to, well, it's pretty much done. It just needs extra features, like, I want a feature that allows me to tell the thing what to do, and I think that can be done. I think it can be done, so I'll get to that eventually. But anyway, do what this sign says and subscribe now, okay?